Hey math fans, test 15, lesson 5. Grab your swords and let's go. Today we're going to estimate surface area, find missing angles in triangles and quadrilaterals, and explain why two expressions are equivalent. And as always, number 1, estimate surface area comes first. So basically, I just want you to think about what you need to know to estimate surface area. Surface area means the area of one surface on a three-dimensional solid. So it's not actually that difficult. All you have to do is think about what do you need to know to find area. You need to know the length and you need to know the width, or base times height, however you want to say it. The point is you need two dimensions in there. So to estimate the surface area, it would be helpful if you knew the base and the volume, for example. Because if you knew that the volume of this thing was 1,000 meters cubed, and that the base was 10 meters cubed, you could make a reasonable estimate. Because if you go 1,000 divided by 10, that gives you 100. You know that the height and the length have to equal 100 in that case. You can make some estimates then based on that and use that to find the area. And sorry, I got distracted there for a sec. Someone just strolled in, but that's basically all it is when you're trying to estimate surface area, you just have to use your common sense. If all I told you was I have a box that is 1,000 meters cubed, could you estimate surface area? No, because that could be anything, right? It could be 1 times 10 times 100, or it could be 2 times 5 times 100, or it could be any number of things. So that wouldn't be enough information. So basically, if I'm asking you what do you need to know to estimate surface area, you basically need to know at least one dimension. If you don't have at least one dimension and then some kind of rough idea of how big the object is, you really can't estimate the surface area. Number 2, we're going to find some missing angles in triangles and quadrilaterals. So this question asks me, in a triangle, what is the missing angle? So we'll start with this guy. I have angle 1, 42 degrees, angle 2, 78 degrees, and angle 3, I don't know. But I do know that the three angles have to add up to 180. So there's a couple ways I could do it. I could do 180, take away 42, take away 78 to get my missing one. But that kind of sounds like a pain because I can look at that and I know that 2 plus 8 is 10. 4 plus 7 is 11, so 40 plus 70 is 110, plus 10 will be 120. I could have also written that out, but it was pretty easy to do in my head. So if those two angles add up to 120, angle 3 has to add up to 180, and using my fact families or just my common sense, I can figure out that that's going to be a missing angle of 60 degrees. So let's take a look at the next one now. This one tells me that I have angle 1 is 90 degrees, and I don't know angle 2 or angle 3, but it does tell me that it's an isosceles triangle. NB, by the way, is just a Latin thing that means make sure you notice. So isosceles triangles have to have two angles that are the same. The other angle can't be 90 degrees because 90 plus 90 is 180, so that would mean there was nothing for the third angle. So these two guys must be the same. 180 take away 90, 18 take away 9 is 9, so that's going to equal 90. 90 divided by 2, because it has to be divided evenly, will give me 45. And we've talked before about how a right isosceles triangle, the other two angles will always be 45 degrees. Now let's have a look at the third problem. So in my third problem, I have that angle 1 is 105 degrees, angle 2 is 60 degrees, and I don't know angle 3. So 105 plus 60 will be 165, and then I know angle 3 is whatever the difference is between 180 and 165. I'm going to do that in my head. If I add 165, I'm going to bounce up to 170, so that'll give me plus 5. And then I'll bounce up to 180, which will give me plus 10. 10 and 5 is 15 degrees. My third angle has to be 15 degrees. So hopefully that's not too startling. It's just a review of what we've already done. Let's take a look at quadrilaterals. The same thing applies for a quadrilateral. If you remember that the angles in a quadrilateral must add up to 360 degrees at all times. So in this first question, I have 60, 120, and 60. So 60 plus 60 is 120, 120 plus 120 is 240. So 360 take away 240. The missing angle has to be 120 degrees. And I actually probably could have figured that out, because if these two are the same, these two are probably going to have to be the same too. This one only gave me one angle, but it told me that my one angle is 90 degrees. If one angle in a quadrilateral is 90 degrees, then all the angles are going to have to be 90 degrees. So all of the missing angles here are 90 degrees. 9 times 4 is 36, so 90 times 4 is 360. And last, I've got a whole bunch of funky angles. So these I'm actually going to have to do some math to work out. So I have 80 degrees, 94 degrees, and 118 degrees. So I'm going to add 80 plus 94 first, because that's easy. 0 plus 4 is 4, and 8 plus 9 is 17, so that makes 174. I'll add in that angle of 118 degrees, and I get 292 degrees. And since I know that all the angles have to add up to 360, if I take out these three, that will tell me what my missing angle is. Oops, sorry about that. So my missing angle is 68 degrees in this quadrilateral. And our final goal for today is to explain why two expressions are equivalent. So you already know about equivalent expressions, but what I want you to be able to do is explain. So are the equations 2b plus 1 equals 5 and 16 minus 14 equals b equivalent? Well, first of all, are they? So 2b plus 1 equals 5. 5 minus 1 is 4, so 2b must equal 4, which means b must equal 2. Because 2 times 2 is 4, plus 1 is 5. On this one, 16 minus 14 equals b. 16 minus 14 equals 2, so b would equal 2. Are they equivalent? Yes. How would you explain that, though? If a little kid said to you, well, why are those equivalent? I don't get it. What would you say? Well, you could use the math, and you could show them they are equivalent, because in this expression, b equals 2, and in this expression, b equals 2. When you have two equations where the variable, in this case b, equals the same amount, then we call them equivalent expressions. So try this one on your own. Are the equations 3m equals 12 and 3 plus m equals 12 equivalent? So just stop and figure out, are they equivalent? Pause the video, and then be able to explain why they are or are not. And when you come back, I'll have an answer for you. So let's start by figuring out if they are equivalent. So 3m equals 12 is the same as 3 times m equals 12. And of course, with my fact families, I know that if that's true, 12 divided by 3 must equal m, which is 4. So in this equation, m is 4. In this one, 3 plus m is 12. So 3 plus 4 is 7, plus 4 is 15. So m in this one does not equal 4. These guys are not equivalent. So I found that out. Then I need to be able to explain it. So for example, an explanation might be something like, these two equations are not equivalent because when you solve for 3m equals 12, you find that m is 4. When you substitute 4 for the m in the second equation, it does not equal 12. Okay, that would be just a simple way to explain your thinking. And that's it for today. You're on to the review. So number 1, if you know the volume of a box, can you estimate the surface area of one face? Why or why not? Number 2, given the following angles, fill in the blanks. So we have a triangle with angles of 112 degrees and 67 degrees, and a quadrilateral with angles of 87, 93, and 42 degrees. And 3, are the equations 5x equals 25 and 2x plus 15 equals 25 equivalent? And please explain your thinking. That is it for me today, and I will see you tomorrow.